I think the first recorded dust explosion happened in a flour mill. So handling, wheat flour in Italy was one of the first documented explosions, and they were the first. NFPA standard came out in 1920s dealing with grain explosions. So it was the first NFPA standard to ever deal with combustible dust, and it was specifically for grain elevators. There's a lot of unique questions because obviously there's hundreds of different facilities. They have different configurations. So there are a lot of unique hazards. So I talked to several people who said, well, I have this bucket elevator located, right next to a wall. It's hard to add equipment. And so you get an opportunity to talk through different problems and sort of offer that consulting. And, how do we address a unique hazard that doesn't fit into the standard box?
Maybe let's talk about the top three, piece of equipment within a grain handling process that we usually focus our efforts on. Can you explain maybe those risks and why they are, we have such a spotlight on those?
The first piece of equipment you normally come upon is going to be a bucket elevator, because those are typically used to lift the grain from maybe the unloading stations up into the silos. Some of the elevators are quite old, or maybe, hundreds of, over 100 years old. They can be difficult to assess the hazards. Sometimes the mechanical integrity is not the best, and it might not be strong enough to, support our explosion protection system. So we have to try to, look at the risk and see, well, how risky is this? Is it, is it something we can deal with ignition source control, or is it able to be protected? So those are the first types of equipment we normally deal with. The other common piece is going to be the dust collection system, because that dust collection is imperative for keeping a clean facility. The worst hazard from combustible dust is from secondary explosions. So having a good dust collection system is important, but at the same time, when you're collecting the dust, that's where you're basically pulling the explosion hazard into that piece of equipment. So that's a very common item that we need to address. We need to figure out how to manage the explosion and fire hazards in the dust collector. And then another big piece of equipment are going to be the milling equipment, so hammer mills and other types of mills, because you're adding energy into the fuel. So you have potential for mechanical sparks, for ignition sources there. You could create tramp metal, or tramp metal can come in and create an ignition hazard. And then depending on how that mill is configured, if it drops into a plenum, that's like the perfect place for there to be a dust cloud, explosive atmosphere sitting, and you have an ignition source sitting right on top of it. So those are, typically the three biggest types of equipment that we're going to look at when it comes to explosion protection in the grain industry.
So let's talk about Fike's Consultancy's offerings, and how often would you say we do perform risk assessments for grain handling organizations a year?
Our team is, people are on the road every week out doing dust hazard analysis, or our European team are doing, the ATEX risk assessments, and, across the world we're going out, there's going to be somebody from our team on site every day. Specific to the grain industry, it's a significant portion of the facilities we're visiting. I would say, maybe 15%, 20% of the facilities that we're offering consulting to is either in the grain handling, or the pet food space, or the food processing space. So it's a significant portion of our consulting projects.
Do you find that those facilities that we help with consultancy and do risk assessments for, do they already have explosion protection? They're looking to improve it, or just kind of reinvest in it, or are they brand new to the concept of explosion protection, or is it a mix?
It's a mix. It depends. I would say it varies regionally. and also varies into the specific segment. So a lot of the, final food production facilities, they're more likely to have, designed and implemented controls. A lot of the, base grain handling facilities or animal feed facilities, they tend to be older. Before there was a lot of focus on, these controls. In those cases, we, just have to take it on a risk basis. They might have a lot of equipment. A lot of equipment needs protection. It's not something you can do overnight. So that's when the consulting comes in, identifies the biggest hazard, gives them a path forward. It might not be something you can do in a year or even 2 years, but you need to identify where the biggest hazards are so you can plot that path to increasing safety.
Working with our customers to realistically provide, a calendar or a priority of what they can meet within their budget. So can you speak a little bit more about that?
When we develop the risk assessment, we look at, what's the likelihood of there being an explosive atmosphere in a piece of equipment, what are the likely ignition sources in there, and we determine, and what's the severity of a specific piece of equipment having an incident. Severity can be a few things. First and foremost, we want to keep the people safe. So if there's a hazard near where people are constantly working or it's an occupied area, that's a significant hazard. But it also can be a critical piece of equipment. So we want to help our customers maintain business continuity. So if they have a bottleneck in their process and you have an explosion in, say a central bucket elevator that is critical to their operations, and that could put them out of operation for half a year or a year, you want to identify that and say, okay, this is a critical piece of equipment. So we use those, what's the biggest potential impact to personnel, what's the biggest impact to your business, and we'll help them, create a list, maybe a few categories. These are top tier categories. This is your second priority. These are the ones that, sure, there's a hazard there, but let's get to those after you've identified these top tier hazards.
So when it comes to the fuel within a grain handling process, of which there are many and with different characteristics, and that's where dust testing comes involved, do you find the fuel to be unique in any way versus other types of industries that we protect?
So when you're handling raw grain specifically, you're going to get, an interesting amount of dust. The grain is dirty and it's dusty, and you'll have cleaning houses, and you'll need to address that kind of light flying material. And that has also a tendency to, produce a lot of fugitive dust. So we have to make sure that really you have good housekeeping in place, you have good dust collection. From a dust explosion perspective, it's it can be easier to ignite. It can be a little troublesome to deal with, but you're still dealing with the dust explosion hazard. The characteristics will be a little bit different than when you have the corn flour or wheat flour or rice flour. It's going to be different than the raw grain. It's just a little dirty, or it's a little mixed. You might have other dirt and other materials mixed in with it. You also might have foreign objects that you have to worry about, so those could be ignition sources. You have to make sure you've removed those from the process when you're dealing with the raw grain. But otherwise, you're still looking at a dust explosion hazard.
Do you have any stories that stand out where you performed a risk assessment and really, it was a unique situation and you feel like you thought to yourself, man, I'm really glad they reached out to Fike, and then tell us, about that experience and then what was the ultimate solution, if any stand out?
Well, sometimes you will see a moderate-sized facility. So they might have, it gets into those multi-silo operations with, a head house and, a big environment, but you might have sort of a small staff. So there's, especially I'll see this in feed mills where, it's a relatively larger process, but there's not a lot of people there. The ones that are critical are when they just don't understand explosion hazards, when they don't realize how critical, say, dust housekeeping is. When you go into an operation and they have just layers of dust on all the equipment. It's important to educate the people who work there, just because they are oftentimes not aware that fugitive dust is going to be such a dangerous item. So, educating them, showing them, videos or photos of past elevator explosions, saying this is what could happen if you allow this dust to build up on your equipment, and just educating the people who work there, because they're the ones that are exposed to the hazard, and letting them know that this is what could happen. It helps encourage them to focus more on housekeeping, focus more on maintenance of the equipment, and just operating better.
I think that's an important note for everyone in this space to understand. We see the numbers of events that happen, the either catastrophic events, which are, let's say dozens a year. I know, and then there's more incidents than just that. But the numbers that aren't accounted for are the ignitions that were avoided because of processes that you helped with or explosion protection. So I think the incident numbers, the reports that we see are the numbers aren't as great as they should be, because it does not account for all the ones that were avoided. Would you agree with that?
Well, yeah, of course. We send replacement vent panels to customers because they've had explosions. We had a customer event yesterday, and they talked about how they have lots of explosions in various processes. And so, yeah, we do have to replace vents. We have to refill our suppression systems because they've activated because there were ignition sources. Some of the grains and some of the materials you're handling in these industries can be quite sensitive to ignition, can have low minimum ignition energies. And so you can have events, and that's why our equipment's there, to protect these systems. People think of it as a nuisance because they have to refill our suppression systems, but they should really think of it as a blessing, because they didn't have an explosion. They filled a vessel with sodium bicarbonate instead of having to, rebuild a dust collector.
For anybody out there that's, a manager of a grain facility, whatever they might do, and they either have questions, like you said earlier, about a unique piece of equipment, or maybe they have old explosion protection equipment on it, or maybe they haven't really done anything quite yet, what would you want them to know about just getting help, either through Fike or another safety company? But what is the process like, and what would be like the first step?
And the first step is to just, document what type of dust you're dealing with, because they will have different properties. There's a lot of empirical data we can look at. Oftentimes it's important to test your specific material, send it out for testing, or just review the empirical data. And then conduct a dust hazard analysis. That's going to help you identify where there are fire and explosion hazards, and it's going to help you rank those as far as how severe they are. And so that's the first place to start, is to identify the hazards in your process, and then from there come up with a strategy to help increase the safety of the operations.